Welcome to solverfy.
There's a reaction between a metal, M, with fluorine. So we have 0.6 mole of fluorine, 0.6 mole of metal. We react with excess amount of fluorine, and then give 46.8 gram of MF2. So what would be the fluorine number of moles in MF2? And then what will be the mass of M in the MF2? And what will be the identity of M? Okay, so for the number of moles of F2 in NF2, is that okay? We have to look at our chemical reaction equation. So from here, I believe it's balanced. This chemical reaction is balanced, and you can see that for every 1 mole of fluorine, we will form 1 mole of MF2. Okay, 1 mole of fluorine will form 1 mole MF2. And also with 1 mole of fluorine, we will also react with 1 mole of the metals. And also for 1 mole of metals, it will form 1 mole of MF2 because the coefficient is 1. So the ratio between those coefficients, essentially is the molar ratio, is 1 to 1. Everything is 1 to 1. So from here, we can see that if we have 0.6 mole of metal being reacted, we will need 0.6 mole of F2 fluorine molecule to react, and then it should also give 0.6 mole of MF2. Okay, so therefore, we know that there was 0.6 moles of F2 being reacted, being in the chemical compound. So therefore, the actual fluorine number of moles in the compound will be 2 times 0.6 mole, equals to 1.2 mole. The reason that I multiplied by 2 is that from here we have 0.6 of F2, and we want to find out the individual F, not F2. So that's why I multiplied by 2. Okay, so what will be the mass of metal in our MF2? So first of all, you just need to find out the mass of our fluorine. Okay, so we have a total mass 46.8 gram mass, the mass of fluorine. So we have 1.2 mole of fluorine. So we have multiplied the number of moles by the molar mass, which would be 90 gram per mole. So we are 22.8 gram, and this is from our fluorine. And this is essentially, we are going to multiply by our molar mass, 1.2 mole times 19 gram per mole. And then we are going to calculate the remaining mass. It will be 24 gram. 24 gram. Okay, so we have to find the identity of M. So we know that we will have 0.6 mole of MF2, and then we think that MF2, for each MF2 you will have 1 M. So therefore, MF2 it will have 1 M. Yeah, we look at the formula is M1F2. So therefore, if we have 0.6 mole of MF2, then the number of moles of our metal will be equal to 0.6 mole as well. Okay, and we know that inside this metal, we have 24 gram of our metals. And what would be the molar mass? We can find the molar mass, and then we can find the identity. Yeah, because molar mass is unique to the identity. So from here, we have the number of moles, and then we have the mass. We can find the molar mass. So if you remember, number of moles goes to mass over for molar mass, and then molar mass will be equals to our mass divided by number of mole. So we are 24 divided by 0.6, and then we should be able to find that is 40 gram per mole. Okay, the next step is we're going to our periodic table and look for a metal that will have roughly 40 gram per mole, and we should be able to find that it is calcium.